Okay, so let's get into the details of the our introduction example. First thing we are going to analyze is the synthesizer part. So the diagram you see here is the synthesizer part only, and you're gonna see that I have enclosed common parts of the synthesizer with the dotted line. So this part depicts the envelope, and this part depicts the oscillator, and this one depicts the filter. Now, from now on, it will be more intuitive if you follow along with the intro.scd open up in the in the SuperCollider, and you can just run the code on the step 1, for example, and then run this, and you will be able to hear the sounds that I gave you in the Google slider. So now, very first thing, if you are looking into learning the application of SuperCollider in this context, is pause the video and try to find the relationship between what you see as a code and its visual representation on the Google slide. If you are here to just to study the kind of general structure of the synthesizer without necessarily delving into SuperCollider, just know that this diagram actually just shows you that it has the common component to the synthesizer, but it uses the SuperCollider specific language. So this is the common ways of making an envelope in SuperCollider. You have to use two UGens with the specific attack time and release time. Now, impulse is a impulse generator, and a BPF is the bandpass filter. Now, notice that there's one envelope controlling both frequency of the impulse generator and also the center frequency of the bandpass filter. Now, envelope without any the default value goes from the maximum value is 1. So if I make a little envelope that goes like up and down, then it's gonna go from 0 to 1 to 0, or near 0 to 1 to near 0 if my envelope is exponential curve. Now, that will get scaled by the specific number that I define in argument. So here, for example, my frequency, when I run it, will go from 0 Hertz to 80 Hertz to go back to 0 Hertz, while my center frequency go from 0 Hertz to 3000 Hertz to 0 Hertz. And actually, you know what? Actually, there's a plus 20 because it's gonna go from 20 Hertz to 3000, 20 Hertz to 20 Hertz over the same time, because we are using the same envelope. The gesture that you're gonna get from the impulse and a bandpass filter are exactly the same, but in a different scale. So what we can control as a human, as a user, are those 5 parameters in my instrument: the frequency, attack time, release time, cutoff frequency, but also the pen position. So right now my pen position is at 0. That's why you're hearing at the center. So in essence, although this may look perhaps complicated, what I have is an envelope controlling the oscillator and the filter, and they are basically going through a pan path so that you can put it into left or right or in the center or anywhere in between. Any kind of synthesizer will do it, right? Any kind of a commercial and synthesizer will make a oscillator, filter, and the envelope, and that's exactly what it is. And it's there's not much control over it, except that when I basically run this code, you are going to hear sound, and I cannot change anything. It's like pressing a piano note. Okay. Now, next step number 2, changes that a little bit. So the loop is like as I said in the other video, is like a sequencer. You repeat things in a specific time. So in a loop, right, I can change the dot weight, meaning that for example, if I have a 0.25 dot weight, that means every 0.25 seconds I'm going to trigger something. Okay, And also, how many times it's going to trigger? It's going to trigger 10 times. So what you're going to hear is 10 notes, okay? Each are 25.25 seconds each. And they will actually have basically the same number for amplitude, attack, release, and the frequency of the impulse generator. Only thing that will change is this part. A counter plus 1 times 200 will change the center frequency. So it's going to basically open the filter in a specific way. So let's actually talk about counter plus 1. Counter plus 1 is the built-in counter. And as you can see here, this code tells you to repeat the procedure 10 times. And counter, basically, the argument counter within a do loop gives you a number starting from 0 and ending at 9. It just counts by just adding a plus 1 up to the number of the repeats you get. So what you're actually going to get is, because the number is starting from the 0, I'm gonna just do counter plus 1 so that the incoming number is from 1 to 10, meaning that my center frequency will go from 200 Hz in the first run, 400 Hz in the second run, 600 Hz in the third, 800 Hz in the fourth, and then go up to the 10th time, so up to go to 2000 Hz bandpass filter frequency. So let's hear that. Okay, good. Now you're gonna hear pretty much the same sound in here. Okay, so now we have an instrument repeating its note in a very specific interval amount of time and in a very specific rule. So right now, perhaps I'm actually playing an instrument, a plugin, 10 times with my as a MIDI note, and then perhaps opening up the filter a little bit. Now, next step is where I think the detail actually makes the difference, quite a huge difference. So step 3 is a modification of this loop using a randomized function. So every time the loop is running, what's inside, which is the rendering of the SI blipper. Now I let the computer to choose certain parameters for the amplitude, attack, frequency, position, and wait time. So 1, 2, 3, 4 randomization. Okay. I think I'm missing something in here. Let me check. Oh yeah, this should have been, sorry, it's my mistake. It should have been a release. So my attack time and release time is controlled by one random number. So every time I run, my note could be as loud as 0.4 or as soft as 0.4 and as loud as 0.7. In a lot of SuperCollider, the scale goes from 0 to 1, 1 being the maximum number, or minus 1 to 1. So here my maximum volume is 1, and this is the number of this is the amplitude of each synthesizer that's being created. And a similar thing happens to the position. So every note that's been created with the loop will have randomized pan position. So you are going to hear some sounds in the left, some sounds in the right, and anything in between. Now, my randomized number could be also multiplied and go through any kind of arithmetic. So right now, for example, if my random number generates, for example, like a 1, my attack will be just a 1 second, but my release time will be 1 times 3 and have a 3 seconds. So right now, what I'm establishing here is that every note that's being created with the loop will have a 3-to-1 ratio between the release and the attack time. But the length of the duration of the notes could be varied in each run. Okay. Now, there are other ways to choose the randomization number. So in here, you see that rand chooses anything between this range, but also I can use .choose, which will choose a member from a list. So every time this goes, my beep route routine goes through, my duration could be either one of these three values: 0.1 second, 0.15 second, and 0.2 seconds. There I only have three choices when I use .choose with the list. In this case, I ran 0.4, 0.7. The choices are almost infinite, or there's a lot, right? And there's a lot of number in between 0.4 and 0.7. Yeah. So here, my wait time, or the sequence of the notes in terms of rhythm is quite quantized into three values, whereas my amplitude and the duration of the notes and the position is quite randomized. And but I'm still specifying the repeat. Now notice that I also have modified this counterpart. Okay, right now in this counter I'm just going through 200 to 2000, like this. But this, what I just did was basically I have more control on this part. Instead of just constantly multiplying 200, I can specify that by using a CF. Now, so what you're actually seeing in the code is a function. A little function is, in SuperCollider you use it with a little tilde and a name. So what I can do is, if I enclose my routine on a step 2 inside a function like this, right? So my routine here is enclosed inside the function and also uses the randomization. Okay, but now what I can do with the function is that I can make my own argument, so that my argument is plugged into the whatever that's inside in the function. What it does is that basically gives me a one-line command. Okay, all these lines that you have here. Now, when I want to just run it, I'm just gonna give one-line command here, and in here my beep route dot value, and inside the parentheses I have a 30, 50, 100. That corresponds to 30, corresponds to how many times it gets repeated. What's the frequency of the impulse, and then the cutoff frequency increment. So here I'm gonna have 30 times 30 notes that has the frequency of the 50 impulse, but my cutoff, my center frequency will go from 100 to 100 times 30, 3000. Yeah. So it sounds like this. Oops. Okay. And then here is the pretty much the same thing, but instead of a 50 hertz, now I have a 15. And you know what, actually let's make it to 5 so you can hear the difference between 50 hertz and 5 hertz. So 5 hertz is basically a rhythm, a tick, 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 tick. You can hear that, but it's still getting filtered by same parameter. Okay. Now when something starts to repeat faster than 30 hertz or more, then you start to hear a pitch. Now you're gonna hear same, right? Same parameters, same setup of parameters, but now the original filtered sound is actually has a pitch at a 500 hertz. Okay, so now in step 3, we basically create an interesting way to control whatever we have just made in the loop and a synthesizer. Okay, so everything we have done here, which has quite a lot of code, but then by choosing what to control and what to show, our goal in function is to create like a one-line command that will control, duplicate, and modify loops and the synthesizers in here. So function, as I said in the previous video, is like a kind of like a preset. We choose certain things to control, and we try to make it kind of neat so that it's ready for the performance. Okay, so now step 4 is where I record the those functions into more musical form. Right, so now I pre-wrote certain presets here. So this could be like a preset 1, preset 2, and preset 3. And then we're gonna run that and run the lines below, improvise the timing. That's basically an instruction for me as a performer. And I also make a reminder that multiple runs are okay. Now, multiple runs are okay because because my function already randomizes the a lot of parameters inside the loop. So even though I run same line multiple times, its details it will be changed. Look, the first run. Now the second run will have a similar sound but different. Okay, perhaps a different pen position, different length, right? Here. So multiple runs are fine. And I could create for example, a pedal 500 Hz sound by doing this. Run once, run twice, third time, and then make some more rhythmic sound. And make a little transition. Now, I could be a little bit more creative so that every run I do, instead of a specific number, I can use the rrand method, and now I have a one line that I can run multiple times, and to create a perhaps a little bit more varied texture in terms of pitch and the frequency, cutoff center frequency of the filter. Now, if I pressed record at the beginning of that procedure, I could have recorded a audio file that I can use in other projects. So, all of these steps were meant to actually have a meaningful step 4, right? So we design the instrument, we create a sequence, and we create some kind of a shortcut and a performance ready code. And then that way, when I want to make music, when I want to create use this as in a more artistic way, then I don't have to think about step 1 through 3. I just have to think about when I should be triggering this and how I should be triggering this. Okay, so that's that shows the kind of one of the creative procedure you can take to make computer music, from designing of the instrument to performance. Okay, so keep in mind that this is an introduction. Starting next episode, we will have more elaborate sound and perhaps more intriguing and interesting example. This one, I don't think I even put the name for this piece. It was an intro piece to show how the next episodes will run in terms of the format and what I'm gonna emphasize. So next I'm gonna show you my project called RMHS, and it's an ambient sound generator, and you can actually go there and see what is in there. Oh, I already have the I'm already working on the Google Slides here, but that you will actually I'm gonna actually change the link so that you can actually see the final products. It's already already on public. Now, if you wanted to see more examples of like this, I'm gonna always put a little link to the more works I did. And here, for example, in this link, you're gonna see my other works that uses the SuperCollider and some kind of algorithms to create music and the way I interact with those SuperCollider codes. Okay, so if you have any questions, let me know. I can be contacted with this email, or you can just put a comment on the video, and I'll be happy to assist you. Right, thank you very much, and I see you next time.